While this subset of AI, known as natural language processing, has produced remarkable results in terms of understanding human languages at a deeper level, it hasn't been applied to its full potential, and that is helping computers understand programming language themselves better. Introducing Codenote. Codenote is a natural language processing toolkit for programming languages. While NLP has been applied to understanding human languages at a deeper level, we haven't even explored what NLP can do in terms of understanding computer languages better. Well, Codenote aims to apply state-of-the-art NLP techniques to understand code at a semantical level, rather than just a syntactical level. This application of natural language processing can help developers of all levels. In fact, there are 3 million people that are learning to code every single year, with the majority of them being students under 24. One of the largest problems that these learners face is understanding other people's code, especially the code that isn't commented. And let's be honest, that's most of the code out there. By leveraging Codenote, users will be able to see and glance at the code by simply looking at an easy-to-read English version of the code. Since Codenote is able to understand the code at a deeper level than simply just a syntactical level, Codenote in the future will also be able to translate languages from one programming language to another. So think of it as Google Translate but for programming languages. After all, it's intuitive to make computer models understand computer languages rather than just simply understanding human languages. Well, all of this sounds good. But how would all this work? Well, to begin, we would need to understand the code and the relationships between different parts of the code. And then we would have to extract the important parts of the code. In particular, when beginners are learning to code, and for also veterans, code deals with a lot of third-party libraries, right? For deep learning, for example, there's libraries like PyTorch and TensorFlow in Python, which are extremely important. Thus, for building a basic sort of corpus for our NLP model, we can basically extract a large code base such as that from PyTorch, and we can use that to train our NLP model. In fact, a lot of these code bases have easy to access and free examples of various code made using their own library or programming language. An example is this is PyTorch as mentioned. You can actually check it out using the link in the description. Well, creating Codenote would be a 3-part process. The first part is dealing with simply the code itself and has nothing to do with natural language processing. And this is the only part of the entire process that is not language agnostic, meaning that this part of the process would change for every different programming language. So what this part looks like is essentially taking code and then creating parse trees out of them. Now, what this means is that let's say you're given a function. Now within that function, there may be an if statement, right? And then there also might be, let's say, a while loop. So as for the function can be broken down into 2 different things, the if statement and the while loop. And then as for the if statement can be broken down further into a true statement and then a false statement, and then which can be broken down further. And then as for the loop, it can obviously be broken down further in terms of the various different statements contained within the loop. Now, creating these various parsing trees would help the computer understand the relationship between various different elements of the code. So this is actually the concept of using these trees is actually used in other parts of programming as well. So there's syntax trees, there's binary trees, and there's a lot of different trees. So we would essentially be using that concept, but applying that to actually structure our code base. And the best part about this process is that since it is so simple to actually add another language into this process, it would actually make Codenote as a whole a very scalable idea. Because to add another language, all that would need to be done is essentially understand the various parse trees contained within that language. And since programming languages are quite rigid in terms of the linguistics, obviously the parse trees wouldn't change much from language to language. It would mainly just be the various processes that occur in the background. Now, once we're able to obtain the parse tree, we can then move on to creating our first natural language model. And that would be dealing with RNNs, which are recurrent neural networks. If you're curious to learn more about RNNs, I actually made another. So from there, parse trees can be fed into an RNN, which is a recurrent neural network. Now, the purpose of the RNN would to essentially take these parse trees and understand these relationships and then actually figure out what this code is doing. So to do this model would obviously need to be trained on various different parse trees and various different outputs. So let's say upon being given the parse tree of, let's say, a code that runs a CNN, obviously the output would be something like understanding that this is actually part of a library known as PyTorch, and then it's obviously dealing with CNNs, so understanding the various layers within a CNN, the various dimensions of the layers, and things like that. So this model eventually would have to be trained on a large amount of data sets, because each data set would obviously be contained within like a small subset. So let's say a subset dealing with deep learning frameworks like PyTorch or TensorFlow, one dealing with libraries like libraries dealing with blockchain, one with data science libraries, and etc. Now, the third step is that once we've obtained the actual meaning and the context of this code, we actually need to output it in a format that humans can actually understand. So what we can do for this is actually leverage generalized language models or transformer models created by Google and OpenAI and various different companies. So the most popular ones, as I mentioned, were Google's BERT and OpenAI's GPT. The later model is called GPT-2, which is much more powerful. Now, the advantage for using these generalized language models is that they're very powerful. In fact, GPT-2 has 1.5 billion parameters and took them many, many days to train. So since I do not have access to that amount of training resources or time, we can essentially leverage these open source tools to help us. Now, this video only deals with realizing Codenote as a concept. In further videos in this series, I will basically be explaining how I built the various parts, as I mentioned, and any updates that come along in the development process. So, as for more information regarding Codenote, you can actually check it down in the links below, and you can also sign up for a newsletter which will keep you further updated regarding any progress made and once features become available and once it launches for beta. To highlight the broad application of Codenote, I would like to give you an example. So let's say I am a beginner to coding, and let's say I don't understand this code in this particular website that I found online and try to debug my code. Well, all I can do is install a Codenote browser extension, which automatically scans for code within a website, and then from there it is able to directly provide summary of that code. Now, you can only imagine how empowering and simple this would be for a learner who's simply just trying to understand what the code means, rather than trying to open up various different tabs and trying to understand this part of the code, that part of the code. Instead, this one simple summary can help the learner expedite their learning process. And as for developers can use this as an auto commenting feature where Codenote would automatically understand the context of the code and provide comments, because let's be honest, while commenting our code may be good for readability, it's very tedious. So that, I would like to end off this episode, and stay tuned for future installments in this series.